Welcome to another video. In this video, what we're going to do is we're going to talk about solving equations. And we're going to start with some really simple ones and then move to some more complex ones. So we're going to try to do 6 different examples. So let's start with this first example here of 1.8 minus m equals negative 5.7. Now we always want to look at inverse operations so that we keep the left and right hand side balanced. So if we have a positive 1.8 right here and there's addition subtraction happening here, we want to subtract 1.8 from both sides. And then we look and we remember that when we have two numbers with the same sign, then we add them. So when we add these together, we get 7.5, and then we take their sign. So now we have a negative m. Don't lose that m. Just drop it, the negative on the m. Just drop it straight down. And then we can divide both sides by negative 1. So m equals 7.5. All right, a second example says negative 4.1 equals j plus a negative 0.5. So the way we want to solve this again is we need to isolate our variable term. So to get rid of a plus a negative 0.5, this basically just says subtraction. So in order to get rid of subtraction, the inverse operation or the opposite is adding 0.5. And we add 0.5 to the other side. So those cancel. We're left with j on the right hand side. When we take negative 4.1 and 0.5, again we're looking at our signed numbers and seeing we have a negative and a positive. So we actually need to subtract them. So when we subtract 0.5 from 4.1, we get 3.6. And since this negative 4.1 has a bigger absolute value, our solution is going to be negative. All right, let's take a look at another one. Notice how in this first one we had subtraction. The second one we had addition. This third one, what we're going to look at is multiplication. So, or actually division. So let's say we have 3x equals 4 and 2/3. So first off, what we want to do is get 4 and 2/3 into a mixed number. So let's say 3x equals, let's do this the quick way. We can multiply here and then add here and then put it over 3. So we say 4 times 3 is 12 plus 2 is 14, and that's over 3. Now our next step here is to get rid of this 3, because we know that 3 of our x's is 14/3, so we want to know what one of our x's is. So if we are multiplying by 3, then the inverse would be to divide by 3. And I'm going to put it like this over here for a specific purpose. Since we have a fraction in 14/3, we can write 3 as a fraction as 3 over 1. So we have 14/3 divided by 3 over 1, which dividing by a fraction is the same as multiplying by the reciprocal. And so then we can take 14 times 1 is 14, and 3 times 3 is 9. So x equals 14/9. For those of you that don't like improper fractions, we can convert that. 9 goes into 14/1 with 5 left over. Okay, fourth problem here. Let's go ahead and take a look at one with another fraction. So we have negative 5/3 x equals 20. Now we could look at this again as saying we are multiplying by negative 5/3, or we could even look at it in the sense of we multiply both sides by the reciprocal. So we can multiply this by 3 over negative 5. Dividing by negative 5/3 is the same as multiplying by its reciprocal. So here we get a 1x equals, we could say 20 times 3 divided by 1 times negative 5. We could do that. 1 times negative 5. And then we can say that this is 60 over negative 5, which is 12 over negative 1, which is negative 12. All right. Let's keep going. We have two examples left. Hopefully you're kind of seeing the same processes repeated. Really, solving equations is just doing the same processes over and over again and just continually working through that. All right, so in this problem here, notice how we have 4x plus 5 all over 7, and that's equal to 7. So what I want to do is I want to get rid of this fraction. So in order to get rid of this 7, since we're dividing by 7, I'm going to multiply both sides by 7. And so these cancel, so we're just left with 4x plus 5, which is convenient and good. And 7 times 7 is 49. So in a sense, what we did is we scaled everything up by a factor of 7. All right, now from here, we need to do a few processes. So I want to isolate my variable term. So since I'm adding 5, I'm going to do the inverse, and I'm going to subtract 5. Those cancel, so I just have 4x on the left, and 49 minus 5 is 44. And then I know that 4 of my x's equal 44, so if I divide both sides by 4, x equals 11. All right, and the final example is 2 times the quantity x plus 3 times the quantity x minus 1, which is equal to 18. Now, the way we can approach this is we need to first look inside our brackets. And within our brackets, we're going to look and say, okay, there's a set of parentheses, so let's work with those parentheses. So we need to distribute this 3. Don't try and add the x and the 3 for a few reasons. One, they're not like terms, and secondly, you have to multiply this through before you can do any addition subtraction in there. So we take 3 times x, which is 3x, and we take 3 times negative 1, which is negative 3. Okay, we'll keep these brackets. We'll drop down this. This was a positive 3x. And we now have some like terms in here in our brackets that we can combine. So x plus 3x is like saying 1x plus 3x is 4x minus 3 times 2 equals 18. So now we need to look at distributing this 2 through. Brackets are exactly like parentheses. They act the exact same way. It's just a step out from parentheses. So here, when we distribute it through, 2 times 4x is 8x, minus 2 times 3, which is 6, which equals 18. Now we're in this comfortable situation of we need to isolate our variable term, so we do the inverse of subtracting 6 by adding 6. Those cancel. We have 8x equals 24, and then we finish it off by, we know that 8 of our x's equal 24, so we divide both sides by 8, and so x equals 3. Now we could go and we could check each of these solutions by plugging it back into our original problem. And we're not going to do that just due to time, but it's a great option to make sure that you are getting the right solution. Thank you for watching. Go ahead and take a look at some of the other videos that I have posted for you.